Hello, everyone. Thank you for coming. So today, Andy and I are going to be talking a little bit about a collaborative effort that actually occurred between Denvr Dataworks and Lubrizol to create a modular data center deployment for immersion cooling. One of the things that we're really excited about talking with you today about is the story over the journey. We hear a lot of talks in OCP about the beginning of the journey, the product design, the product development, the early pre-commercial testing, or even later stage commercial testing of individual products and components. What I'm really excited about in this talk is actually talking about the results. What is the experience of immersing a server like at the data center? We're going to be talking about a multi-year deployment here. So key takeaways, some key learnings. Our data center in Calgary has been operating now for 3 years straight. So I feel like we have a pretty good comfort level with immersion. I just want to share with the audience some of our takeaways and some of the really nice test data that we've generated in collaboration with the Lubrizol team. So if you attended the keynote, you probably already heard quite a bit about Denvr Dataworks. Denvr Dataworks was founded in 2017. We're an AI neocloud. What that means is that we serve researchers, startups, and enterprise operations on their AI journey. We're vertically integrated, which means that we actually have a hand in the design, the operation, and the services associated with the entire stack, which means all the way from the infrastructure to the hardware to the cloud services and platform that sit on top of it. In OCP, we're pretty highly engaged, both in Immersion, in the Immersion Solutions Committee, but also in the new AI NeoCloud Committee. Andy?
Yeah, Andy Richenderfer, Senior Research Engineer for Lubrizol. I'm also the OCP workstream lead for the advanced cooling techniques. So if you're interested in some thermal performance and setting a test specification, I encourage you to join our workstream. Lubrizol is about a 100-year-old company, largely focused in the lubricants and automotive transportation sector. Although we do have a few products for things like beauty, personal care. We can think of face creams and shampoos and things like that. If you want to go to the next slide. So as Amy mentioned, today we're going to really be talking about the deployment at Denvr Dataworks and the partnership between Denvr Dataworks and Lubrizol. And that really started back when we first met over at OCP.
So we met at OCP actually in 2022. Our teams talked to one another. Our data center actually had been, it had been deployed. We decided to actually do a fluid swap. So we switched out our original fluid in our immersion tanks and replaced it with Lubrizol fluid around 2023. So while our modular data center has had immersion fluid in it and has been operational for 3 years straight, the data that we'll be presenting today is the result of the final 2 years from 2023 to 2025. At the end of the day, I think a lot of people in this space that are exploring whether to implement immersion, how to implement immersion, whether the complexity of a new technology is worth it, what it always comes back to is what does it unlock? What type of ROI can I get from this investment? And I'm going to give a couple of examples of the ways that we have benefited from it at Denvr Dataworks. One of the biggest things is power. So we have a lot of efficiency gains that come from deploying our equipment in an immersion setting. We have about overall 40% energy savings. What that does for us is it allows us to have a lot of business flexibility. You can almost think of this as two different paths. If you have unlimited budget, what you can do is you can actually increase the amount of servers that you have in your data center within the same power envelope. So you get more capacity out of your deployment. If you have a fixed budget or maybe you don't want to increase the scale of your actual server capacity, what that means is that you can deploy and you can have quite a bit of flexibility. You can connect to stranded power and operate at a reduced power envelope. When we think about deploying an immersion and just deploying AI data centers in general, a lot of the infrastructure decision-making is centered around power. So this is a huge unlock for us. When we talk about power, oftentimes we often reference power usage effectiveness, or PUE. For immersion specifically, we see quite a few benefits. One of them is actually on the PUE. The global average PUE is about 1.58. The Denvr Dataworks modular deployment actually is able to be below 1.04. At full utilization and at higher TDPs, which is where compute is actually moving in the future, we get below 1.03. So this is a significant improvement for us. This is something that is really, really exciting for us on an operational perspective, and one of the key reasons why us operating with Immersion just makes sense. The other reason why this makes sense to us is it allows us to unlock density. We're an AI neocloud. Density is one of our core goals and aims when we build these data centers. Here you can see a picture of our first deployment. It's located in Calgary. You can see the Denvr Dataworks modular data center in yellow up front. We're co-located with an air-cooled facility right behind us, and it's shown in red. Look at the size difference there. What you can see is that the air-cooled colo, you can get about 1 megawatt per 6,400 square feet. With the Denvr Dataworks modular data center, what we're able to do is get about a 10x density improvement. We'll get about 1 megawatt per 600 feet. So again, significant energy savings, significant density savings. The other thing I think that holds people back maybe from adopting or implementing immersion is not really understanding the thermal environment and the benefits and advantages you get from a hardware and component perspective as well. We have over 2,000 parameters that we're measuring in inline telemetry. We really operate our data center with a very high degree, I would say, of professionalism. So this telemetry allows us to have functional controls, safety controls, safeguards, operational controls. We're able to set limits to meter and to think through things like proactive service and maintenance. On the left, I've given an example of a couple of things that we would see on our dashboard, things like inlet temperatures or outlet temperatures. But also, I want you to look at the right. You don't typically get excited about data that's a flat line. Data that's a flat line is pretty uninteresting for most people, but for us, that is really exciting. That's what we want to see. What you're looking at here is our inline monitoring for fluid viscosity, fluid dielectric constant, density, and temperature. You want this flat. You want everything in your deployment to be as predictable as possible. And the temperatures are consistently incredibly low. We're operating in the 30 to 40 degrees Celsius range typically. What that means is you don't have thermal expansion, contraction cycles at your hotspots. Your components will survive a lot longer. At the overall data center level, we also see a significant impact. One of the reasons why I'm really excited to be here in front of you all is because we've been operating this for 3 years, as I said. That flat line on the previous slide, it's complemented by data that Andy will share a little bit later in the talk. We have had an amazing experience with immersion. It's fairly low complexity for us. We have had no issues at all with the fluid, with any contamination, with any aging, with any deviation of properties over time. These fluids are formulated for much harsher environments. And so the longevity of these products is significant. The IT equipment reliability is also quite strong. I gave the example in my keynote of the A100s that you see pictured here. You generally don't talk about A100s or last generation at a tech conference. But for us, this is really important. These were state-of-the-art 3 years ago when we deployed them, and they're still operational. They're still doing a great job to serve our customer needs. And there is still a healthy demand by our customers for those types of compute for their AI workloads. We are able to actually see that 98.8% of those GPUs that were deployed 3 years ago are still fully operational. We also have been able to work within OCP in the community. We're very heavily involved. What we've seen is a consistent experience with compatibility of some of the other components like cables. Cables, labels, PVC, those are known component materials that maybe don't have great compatibility. Our experience is very much reflected that of the OCP guidance, which I also see as a good thing. We're seeing consistent results throughout the community. The last thing that I also want to mention is as we move beyond the A100s, as we talk about new generation or next generation equipment, something that's really important to think through, I don't emphasize it a lot here in this talk, is the performance. that at the end of the day is the most important part, right? We haven't seen any thermal issues with our equipment. We have seen significant advantages when we're able to design, optimize these servers for immersion. So again, choosing the right components is really important. Designing the servers to be properly immersion ready is very important. It gives you performance benefits. And the immersion community's experience very much reflects our own. The last thing that I wanted to mention is risk. This is one of the reasons I think that people hesitate to adopt new technology. Denvr Dataworks is a startup. We recognized that there were a lot of business advantages for us, and we took the risk. But we learned a lot of things along the way. 3 years ago, when Denvr actually deployed the data center, there wasn't a lot of common knowledge that was publicly available. There wasn't a lot of equipment that was available that was purpose-built for immersion. This is a significant challenge that's being overcome in the market today, and it's something I'm very glad to see. What we actually did 3 years ago, because there was a lack of guidance, there may have been a lack of appropriate equipment available, is we made sure that we hired the right subject matter experts. We hired the right people, we partnered with the right people to make sure we were making smart strategic decisions from the beginning. Across our team, we have multiple gigawatts scale of deployment history. That's really important. There's a professionalism and a maturity that you need to bring to this operation. We have all sorts of extra training, which I'm sure everybody in the room has been subject to in their own companies. Nobody loves training, but it's really, really important for immersion. It's just different than air. It's something that you just have to have special training for your staff. It's really easy to accomplish. It's really easy to operate within. The second thing that I wanted to share with you is the application-specific design features. We see significant advantages both to density and to the thermal performance when you optimize for immersion. What that means is making sure you're using things like the correct heat sinks, making sure that you're optimizing for fluid flow instead of airflow. It's not rocket science, but I think that this is something that reflects the evolving maturity of this market area, that more products are now becoming available for this specific environment. And that's great. That means the demand for these products is also going up. The other thing is that we want to mature our own internal policies and procedures. Back in the early days of Denvr, we did our best. We learned a lot. And as we're learning, we're also expanding our own procedures, our own operations, our SOPs to ensure that we have safe operations. We're contributing within OCP as well to actually talk through some of the failures that we've seen and some of the outcomes of those failures so that we can design around them. So all of those things are really important for us. What I'd like to just emphasize here, we only have 15 minutes to talk. We wanted to share as much of the story as we could in that small amount of time. But it's really important just to say that we have had a highly performant data center experience using immersion cooling. It takes some thoughtfulness, it takes partnership and collaboration, but at the end of the day, it's worked really well for us. And I am very glad to see that the community is also growing, that is interested in deploying their own immersion technology.
Strong message. So I'm going to talk a little bit more about the fluid story. And when we look at the health of the fluid, we like to break it down into 3 components: performance, safety, and durability. When you look a level deeper and you're looking at the properties that are involved in each of those, it's the usual suspects, right? For the thermophysical properties, density, viscosity, things like that, I gave a presentation last year that you can look up that shows how the performance of the fluid changes when those change. For safety, the dielectric properties in order to ensure the compute is performing and protected as it should be, and perhaps also things like flashpoint for fire safety. For durability, you're sort of looking at what's coming in and what's going out of the fluid. Is there antioxidant depletion? Is water ingressing into the fluid? These are all the things that we want to consider. And then as far as monitoring goes, Amy showed some really great data of in situ monitoring. It doesn't quite replace the advanced analytical techniques that we have available in the lab. So that's a point I really want to stress because, I think at some of the presentations earlier, you saw, ICP, GC mass spec, right? Those are all going to be very important. So you can get monitoring in the system, but you should still sample and lab test after the fact. So as we dive a little bit deeper into the data, a quick primer on electrical resistivity. it is a spectrum. It starts at insulating, and that's where a lot of base oils will start. Can go all the way to conductive. That's where water is. The compuzole fluid that we formulate it to be in this anti-static region. And the reason why we do that is a phenomena called flow electrification, in which as the dielectric fluid flows through a pipe, it can build up static charge. If the fluid is in the anti-static or static dissipative regions, it can actually dissipate that static charge and protect the entire system from a discharge event. I'm also going to continue the trend of flat lines. Again, it's not very interesting, but we do see that both electrical resistivity as well as dielectric constant, we have the line there at 2.3 to indicate, that's where the OCP reference is. We sit underneath that, and the line is very flat and very uninteresting. Great for the deployment, not so great in presenting. We do have a little bit more interesting data on the next slide here. Kinematic viscosity, kind of as Amy showed, really lines up between the lab testing and the in situ testing. That's great validation for us. We finally see something that isn't a flat line, water content. And it was a little surprising at first, but then you think a little bit more critically about the application. And humidity varies over seasons. So as your deployments go from weeks to months to years, things are going to change like the seasons. And so a wet summer or a dry winter, right, that's going to change the amount of water content in the air and how much can diffuse into or out of the fluid. And we actually see that as a result. Now, I'll remind you that this is very little water content. This is about 100 ppm. And we also already saw the dielectric properties didn't change. So there's actually no issue with this, but it's interesting that we can track it nonetheless. Now, a more powerful message besides flat lines is when you can demonstrate when the line isn't flat. So if you can actually demonstrate failure, that you can show failure through data and monitoring, that says that we're behaving as expected, but we also know when things can go wrong. So we created a test in which we synthetically made things go wrong. So we set up a test in a similar test rig as to the presentation I gave last year, and introduced 400 ppm, so 4 times the amount that is typically in there from just saturation in the air. We introduced 400 ppm water in 20-minute intervals into this tank and tracked the monitoring of the fluid with our in situ sensor. And you can see very clearly viscosity, dielectric constant, resistance, they move all in the directions that you would expect them to move. Viscosity, for instance, when you get enough water in there, you can start getting entrained droplets, and that can actually increase the viscosity, even though water is a little bit less viscous than the most of the oils here. Dielectric constant and resistance, right? Those trend upward and downward as you might expect. But it's a strong message that yes, we have flat lines, but also we can detect when the line goes a little bit askew on us.
Thank you, Andy. So just to summarize some key learnings from our multi-year deployment here. In terms of performance, over those 3 years, we've been able to scale immersion with reliable performance and uptime. This is something that for us is a very low-touch operation. It's very straightforward and simple. It does require some upfront work in order to make sure that your employees are properly trained, but once it's in operation, it's smooth sailing. It's a very, very mild and effective environment. We are able to get significantly improved density, and also we're able to get improved energy use, footprint, and TCO savings from this. So this isn't a science experiment. This isn't something that just improves performance or just improves power. It actually impacts the bottom line. It gives us business options, which is really, really important when you're an AI neocloud. You need to stay agile. In terms of material compatibility, what we actually have implemented over time, recognizing some of those observations from our initial deployment, was that we need to have a better relationship with our upstream vendors across the board. So we actually have implemented pretty strict vendor partner requirements in order to approve all of the components that go into our data center. This helps us to de-risk our operations, and guidance from groups like OCP allows us to actually point to industry standard references. These are things that are community approved. These are guidance packets that are community approved. Let's make sure we're following all of these best practices. Rigor and safeguards are incredibly important. Safety is incredibly important. I don't just make data centers. My employees, my colleagues, my friends, they work in these data centers, and I want them to be safe. It's very important. It's not very difficult to maintain a safe workplace anywhere. The specialty chemicals industry, the oils industry, they've been doing it for decades. All it takes is a little bit of maturity in the IT industry in accepting these new technologies to implement best practices for systems design and employee safety practices. The last thing, and I think actually the most important thing for me and probably a lot of people in the room, is the shared innovation. So having groups and communities like OCP, having collaborators like Andy and the R&D team at Lubrizol have accelerated our own journey at Denvr. We know that this community can accelerate each other's journey as well. The entire outcome that we're all striving for is to de-risk our own operations. By working together and collaborating, we're able to do that. So in closing, let's work together. Reach out to Andy or I if you want to talk more. We'd love to hear from you. I know Andy's sitting more on the fluid side. We're sitting more on the NeoCloud side. We're both happy to share. So thank you very much for your time. I think our time is up, but we might have a couple minutes buffer if anybody has Q&A. No? Okay. We do not have time for Q&A. So if you want to talk to us, Andy and I will stand outside the door, and we're happy to answer your questions there. Thank you, everyone.
Thank you.